All right, today we're going to work through vector addition. When we talk about vector addition, we first off want to talk about the coordinate system and making sure we're good to go on the coordinate system. So remember, we are north, south, west, and east. Okay. Now we can put that up into degrees. Your east direction is going to be 0. Your north direction will be 90 degrees. Your west is going to be 180. And then your south will be 270. And then all the way around back to east, we've gone all the way around 360. So if we've gone around one time, it's 360. If we go around 2 times, 720, so on and so forth. So if we're somewhere beyond 360, so let's say it's 360 and 90, we have a 450 degree. What it's done is gone around and then back up to the top. Okay. So that's kind of an important thing to know. If it doesn't give you any information as far as a direction, you're going to assume east is 0, and we work from there back up to the 360. Okay, that's one way we can do it. Another way we can do it is by individual spots. So let's say I have my line drawn here, and let's say that this is let's call it 30 degrees. That's a 30-degree angle right there. So if that's a 30-degree angle, I can say that this is 30 degrees, and the direction is going to be east of north. Okay, that would be one way I can do that angle instead of saying it's 60 degrees. So sometimes you'll see it written like that. Or I can have something, I could take the same angle. If it's 30 degrees east of north, it would also be 60 degrees north of east. Okay, so sometimes they're going to give you just different ways of writing things. Just be prepared for that because we have vectors all over the place. Okay, call that a 20-degree angle. We can say that that's 20 degrees south of west. Lots of different ways. We will see all of them. Okay, let's add some vectors. Now remember, when we draw vectors, we're going to represent them with direction and magnitude. Okay, so if I have one that's going this way, a vector angle is going this way, my magnitude is going to be higher on that first one than the second one I just drew. Okay. Both of them have the same direction. One's got the higher magnitude, and the reason it has the higher magnitude is because I drew it that way. Okay, so we want to get as close as we can to actual magnitudes. That way our brain starts thinking, oh, that's actually where it's at, and not something like this one's 10 times bigger than that one. Okay, no, we want something that's halfway close to what it should be. Okay, so that's one way of looking at it, is we're going to draw our vectors in the correct size, or at least to scale. Okay? Now if I want to add vectors, okay, so let's say I have one thing pushing in this direction, and I have another thing pushing with equal magnitude in the same direction. So basically we have 2 people, let's say, pushing a car. If I'm adding these things, what they do is we call the tail to tip method. So we add the first one, and then we have the tail of the one to the tip of the other. So overall, we have a vector that looks like that. Okay, so we can graphically show these 2 vectors going together. Okay. What if I have a vector at this length, and then I have another vector going back, say, that length? Okay. The tail to tip still works. I can take my first vector, I can draw it, and then add the tail to the tip. It's going back the other direction. Where's our resultant? Where do we end up at? We end up right there. So we end up with something that looks like that right there. That's being our answer. Okay? Because we still have more going in that direction, even though that last one went back towards the origin. Okay, so straight lines are pretty easy to work with. It's not until we start getting angles. Now remember the other day we started talking about knowing your components. So if I have an angle right here, we said draw it out, set up a triangle. Okay, what we're going to be solving for is we will solve for x components, and we will solve for the y component. Remember, x components, if it's going towards the east, if it's going towards the right, that is going to be a positive unless they give us some other definition of what positive is. The y, if it's going up, if it's going towards the north direction, that will also be positive unless they give us another direction. Okay, so we want x's and we want y's. What we're ultimately looking for is we're looking for what we're going to call x total and y total. Okay, so that's what we're looking for. We're looking for x total, we're looking for y total. So this is pretty much just pretty easy. It's just all summative. We're adding stuff together. So if I have, let's draw a bunch of triangles, or a bunch of angles. I have this one, I have this guy, let's go back the other direction, and let's make it just like that, straight across. Okay, all we're doing is we're looking for x components, y components. So this first one, basically, let me talk about. Let's say what these are. Let's say Johnny is walking down a path. He is walking on a path that's 45 degrees east of north, or north of east, or we could just say 45 degrees because 0 degrees is assumed to be east. So we are going 45 degrees east of north. And he is walking with a magnitude of, let's call it 2 meters per second. Okay? And this angle here is 45 degrees. All right. Once he reaches that location, he sees a butterfly on the path, and he walks for, let's call it 5 meters per second. Due north. Okay, that's an important word. You hear due. Okay, if we're going due north or due east, due west, due south, that means you're going straight that direction and not off the side. There's no angles there. So if we're going due, anything that says due, we're only going to have one component. We're not going to have x and y. We will either have x or we will have y. That's an important thing to remember. Okay, so here's direction 2. Okay, after spotting the butterfly, a squirrel catches his attention. And he walks, let's say that this is a 30-degree angle west of north, and he is traveling, that's a squirrel, he's excited, 6 meters per second. Okay, so he's going 6 meters per second in that direction until he realizes it's not a squirrel, it's really a bear, so he travels 10 meters per second due east. Okay. Those are all directions. That's all of somebody walking somewhere. Okay, so if we have these things, we can add them all together and figure out where he's at the end of the day, okay, or at the end of whatever he's doing. So we have to first off put it off into separate little things here. We want to separate it. This is our first thing that we're doing. Then he has activity number 2, activity number 3, and activity number 4. Okay, it's just like when we were diagramming things earlier, we had to separate it into smaller steps. We're doing the same thing. We're going to separate into smaller steps so we can get to our total. Okay, so we have activity number 1. And activity number 1, we have him traveling at 2 meters per second at a 45-degree angle. Okay, can we solve for x component and y component? Yes. Are we going to do that right now? No. But what I want to do is show you how I would set this up. I would solve, notice I wrote x total and y total over here. I'm going to say x sub 1, meaning that's the x for my 1, the first thing that I do. And then it equals, and we solve for it. Okay. Now we solve for it using SOHCAHTOA. We are going to use a lot of geometry right here. Okay. Can we solve for our y components, which we're going to call y sub 1? Yes, we can. Now, the biggest things on these is remembering what's the positive direction. Remember, if we're moving to the right, we're moving up, that's going to be positive. If we're moving to the left or down, we're going negative. Okay, so we have positive, positive here. Awesome. Okay. X sub 2. Y sub 2. In this case, we're going straight up, or due north, not really up. So if we're going due north, do we have an x component? No, we do not, so it'll be 0. We can actually put that in there. Okay, do we have a y component? Yes, we do. In what direction? It's going north. So we know that that's going to be positive. You can solve for the number. In fact, in this case, it's going to be 5. I'm just not going to put it in there right now. Okay, but know that that's going to be 5 there. Okay. For 3, we're going to have an x component and a y component for this one as well. So this is going to be x sub 3. Sorry, I wrote a 2 there. X sub 3. And we're going to have a y sub 3. Okay, important things to remember. Our x, what direction are we going? We're going back to the left. Okay, so our x in this case is going to be a negative. Okay, our y though is still going up, so what's our y? Our y is going to be a positive. Okay, and then we look at our last one, our 4. We're going to have an x sub 4, and we're going to have a y sub 4. Okay, our x sub 4 is going to be positive direction, so it's going to be positive. In fact, it's going to be 10 positive, and then our y doesn't exist, so it's going to be 0. Okay, so vector addition, what we're going to do now is we're just going to take all these things, we're going to add them up. Okay, so we're going to add them up, it's going to give us an x total, it's going to give us a y total, and then we'll be able to work from there. Okay, so I'm going to get those totaled up here in just a second, and then we will work with an angle. Alright, I've substituted my x and y values in for x sub 1, y sub 1, x sub 2, y sub 2, so on and so forth. And I've gotten my totals. Okay, so my x total is going to be 11.6. That's going to be meters per second. And my y total is going to be 8.4 meters per second. Now I could plot this onto a coordinate system. So it's going to look something like this. Okay, so I'm out here, here's my coordinate system. My x total is 11.6, so I bring that out. So let's call this 10. So if that's 10, then my 11.6 is going to be about right there. Okay, my y total is going to be 8.4. So again, if this is my 10, it's going to be just inside of that. There's 8.4. Okay, we extrapolate over, and we end up with the point that's way out here. Okay? That is pretty much our ultimate trip. That's where we've gone. Here's where I see people have problems. So write this down or just look at it and know that this is not how you do it. I see people, they draw this point, they draw that point, and then their triangle looks like that. Don't do that. You're going to go through the origin. Okay? You are going to go through the origin. So I'm going to get rid of that, get that out of your brain. That's just a common mistake that we make. So we extrapolate over, and then we draw the line. Okay? So if I have this line and I know that my x component is 11.6, and I know my y component is 8.4, I can then take that information and I can solve for my angle. Okay, so what I want you to do tomorrow is I want you to come in, I want you to solve for what theta is. Let's see if you know your triangles, and we'll take a look at that. Show me what you got for this answer, and we'll see you tomorrow.